Hi to everyone. School of Engineering, Department of Mechatronics Engineering, online classes, analog devices and circuit. Myself, Sarunan, Assistant Professor, Department of Mechatronics Engineering. So last class we discussed with the basic SCR and track. That is the basic switching devices used in the different circuits. So it is having some disadvantages like that power loss and efficiency less like that we have. So for this purpose, we are using the FET. Okay, that is field effect transistor. So field effect transistor is a semiconductor device which depends for its operation on the control of current by the electrical field. So FET has several advantages for the BJT. That is current flow is due to the majority carriers only. That is immune to the radiation, high input resistance. That is less noisy than BJT. No offset voltage at zero drain current and high thermal stability. So this is the JFET symbol. So that is we have two channel, that is N channel and a P channel JFET. So that is in N channel, the arrow mark will be defined as the into the circuit. That means where the electron will get into the circuit. So it is called N channel. So P channel means it will receive the electron. So it will be the arrow mark will be getting out. So these are different classification of field effect transistor. So generally it is defined as the junction field effect transistor and metal oxide semiconductor field effect semi field effect transistor. So it is have N channel and P channel. So it is have depletion type and enhanced type. So in this type it will be divided into the P channel, N channel and P channel enhancement type and N channel enhancement type. JFET. So based on the constructions, JFETs are two types. One is N channel and P channel. That is N channel means the total material that is substrate will be N type. If it is P channel means the substrate will be P state. So P type. That is the concept. The substrate what? So what is the substrate? Like that we can define the channel. So that is it is a major part of the this FET. So this is called a N-type model. So the P-type materials are defined fixed in between the fixed in the N-type substrate along with the gate terminal. Okay, it is having three terminal. One is drain terminal, another one is source. So another one is gate. Okay, here gate always define the rate of flow. It is gate voltage. It will define the rate of flow current between the drain and the source. This is the basic symbol of the NFET, N channel JFET and a P channel JFET. Construction of N channel JFET. So definition of source, drain and gate. The source is the terminal through which majority carriers enter the silicon bar. So drain, the terminal through which majority carriers leave the bar. Then gate, control the drain current is always reverse biased. Okay, that analogy, the operation of FET can be compared to the water flow through a flexible pipe. When one end is pressed, the cross-section area decreases, hence water flow decreases. In FET, drains is similar to outlet format of the draining system, as well as gate is similar to controlling the process. So like that. So this is the model principle used in the JFET. So these are basic operations to control the drain current. So FET makes use of the channel formed in by space charging region between the gate and the bar. By increasing the reverse bias, the width of the phase start region decreases. As a result, the channel resistance increases, the drain current decreases. So this is the model. So see one by one. So this is the difference between N channel and P channel. So here source connected to the minus VE. Here source connected to the positive VE. So here in N channel drain connected to the positive. In P channel drain connected to the negative. So in channel gate connected to the negative. In P channel gate connected to the positive. So that means if N channel means gate bait always will be negative because then only it will oppose the value. So gate always reverse biased. Okay. So when voltage is supplied between the source and drain, the majority carriers moves through the channel between the depletion layer. The value of drain current is maximum when no external voltage applied between gate and source. So when the gate to source reverse biased, increase the depletion region, widens and the channel with decrease, hence drain current decreases. Okay, these are the explanations. There's a difference. So parameters. So DC drain resistance that is defined as the ratio of drain to source voltage VDS to drain ID, also called static or ohmic resistance. AC drain resistance that is defined as the resistance between a drain to source when JFET is operating in pinch off region or saturation region. Difference between FET and bipolar junction device. So see one by one. FET will be unipolar device. So BJT will be bipolar device. This voltage control, this is current control. High input impedance, low input impedance, better thermal stability. So low thermal stability, high speed switching, low speed switching. So these are the different difference between the FET and BJT. Drain characteristics of the FET. So disadvantage of FET. So FET have a drawbacks of smaller gain bandwidth product compared to the BJT. This is the another disadvantage of the FET. BJT. So the high input features, the high input impedance, low output impedance, and the low noise level make FET superior of the bipolar transistor, as well as application as a buffer amplifier, which is isolate the preceding stage from the following stages. So FET applications, it is used in the phase shift oscillators, voltmeters. So like that, it will be this. So let's see the MOSFET, that is metal oxide semiconductor FET. So it is having two type depletion and the enhancement. So each type depend as the P channel and N channel. So this is the model of the N channel MOSFET and the P channel MOSFET. Okay. So enhancement model. So what is my enhancement model means? Normally it will be off. So in depletion type, normally it will be a on condition. Yeah, this is the difference between these two. So in depletion type model, depletion type MOSFET, so there is small N-type channel connected between the input. In the enhancement type, so there is no channel between the input and the output. Okay, channel that is depletion layer type. So there is no channel means enhancement type MOSFET. So this is the depletion layer MOSFET cross section area. That is a substrate aluminum. So diffusion channel depletion region and SiO2 insulation. Enhancement MOSFET. That is induced channel. That is channel will be produced. So when the power supply givens. Okay, but in the already in depletion MOSFET, we have a N channel, small N channel in N type material. So the layer will produce between the that is N channel. So these are base substrate conditions. Same model constructions symbols already working path down. Okay, let's conclude with the JFET and the MOSFET differentiation. So JFET gate is not insulated from the channel, but in MOSFET it is isolated from the channel. So channel and gate forms two P junction in JFET. Channel and gate forms parallel plate in capacitor. So here they in JFET they have three leads. In MOSFET they have four leads. Same as input impedance high in the JFET, input impedance is very high in the MOSFET. So gate current is more in JFET. Gate current is very less and easy to fabricate and chip. Advantages of MOSFET over JFET. The insulated gates in the MOSFET result in much greater input impedance than that of JFET. It is easier to fabricate MOSFET than JFET. So MOSFET has no gate diode. So this makes it is possible to operate with a positive and negative gate voltages. So these are the different applications of MOSFET. High input impedance electrometer circuits, then high complex digital arrays we can use in the MOSFETs. Okay, thank you. So next class we will see the rectifiers and filters.